Alright, well in this video we are going to be looking at something called a p-value. Now as we start getting into hypothesis testing, p-values are something that are super important. We're going to be seeing p-values lots and lots from here on out. So to start off, what is a p-value? And basically the p-value is the probability of seeing our observed data given that the null hypothesis is true. So if you think about when we're doing a hypothesis test, we have a null hypothesis. That's the claim that is being made. So someone somewhere is claiming something is true. And our job of doing a hypothesis test is to basically try to either validate or argue that. Now, given that the null hypothesis is true, we're assuming it's true going in, we want to see if that's true, how likely is it that the data we actually collected for our sample, it fits with that null hypothesis. We want to see how likely it is or how surprised we would be to see that data. Now, the p-value, basically we want to know what it tells us because it's just a number, so you have to know how to interpret that number. When the p-value is small enough, it says we're very surprised. So if you get a very, very small p-value, it says, assuming that that hypothesis is true, this data that we collected doesn't make any sense. Okay, it says we are very surprised that we collected this set of data if that null hypothesis is true. So it's unlikely that we would actually observe these if the null were true. Thus, we make the decision to reject the null hypothesis. Now, when a p-value is big, it says if that null hypothesis were true, we're not surprised at all that we collected these data. This set of data matches pretty well with that null hypothesis. So, therefore, we make the decision to accept the null hypothesis. Now, one thing that is very, very important, we don't ever say that the null hypothesis is true or false. We don't know, okay? We don't actually ever know if it really is true or really is false. We just have data that supports a decision to either accept or fail to accept. We are not making the claim that anything is true or that anything is false. We're just simply accepting it based on our data, or we fail to accept it based on our data, okay? Now, a couple of questions just to get you thinking about a p-value. And this is, before we even learn how to find it, just a couple things to get you thinking about it. Question number 1, a research team wants to know if aspirin helps thin the blood. The null hypothesis says it does not. So we're up front, someone's made the claim that aspirin does not help thin the blood. They test 12 patients and they observe the proportion with thinner blood and get a p-value of 0.32. They proclaim that the aspirin doesn't work. What would you say? So a p-value of 0.32 is not a very small number, okay? We typically test a p-value at 0.05. And that's kind of our cutoff of whether if it's below 0.05 or above 0.05, that's how we kind of make our decisions. So when we see this p-value of 0.32, it's not all that suspicious. It makes sense. Our data that we collected makes sense with the null hypothesis and the null hypothesis says aspirin does not. So they then make the claim aspirin doesn't work. What would you say? Well, their big mistake right here is making the claim that aspirin does not work. Okay, we can't say that. We are not able to say if the null is actually true or actually false. The only thing we can say in answer to this question is based on our data, we are unable to reject the null. Okay, we are unable. The data that's been presented to us does not allow us to reject it, so we're going to say that we accept the null hypothesis. We're not saying that the null hypothesis is true, but we're saying our data supports that we would accept the null hypothesis. Okay, question 2. An allergy drug has been tested and found to give relief to 75% of patients. Now scientists want to see if a new and improved version works even better. What would be the null hypothesis for this test? So your null hypothesis is the initial claim, and this company is making an initial claim that this drug relieves allergy symptoms for 75% of patients. So anytime we set up our null hypothesis, it's H sub O. And then in the first spot, you're either going to have mu or you're going to have p. So we're either talking about a mean or we're talking about a proportion. And in this case, we're saying 75%. So p, and we're saying that it helps 75%. So we're saying that the proportion that it helps is 0.75. Now, kind of going along with this one, question 3. The new drug is actually tested and the p-value is 0.0001. What would you conclude about this drug? Well, a p-value of 0.0001 is very small. So what we could say in this case, we can't say that, that's true or false. We can say there is very strong evidence against the null hypothesis. Okay, thus we reject the null. Again, you cannot make the claim that the null is either true nor false. We just use the evidence that we have to support either accepting or failing to accept. So, such a small p-value is very strong evidence against the null. Thus, we reject the null in this case. Okay, so just a little bit on p-values, and hopefully that will be helpful when you actually come to calculate them.